Okay. So look at our half sheet. And I think this formula is one of the easiest formulas that we will cover this chapter, and it's the formula for work. So to find work, you need to take force times distance times the cosine of the angle. So when I read this question, it tells us that a boy pulls his brother in a cart with a force of 18 newtons. So that would go here. If the rope pulling the cart forms a 35-degree angle, so that's my angle, that's going to go here. With the ground, determine the amount of work done if the boy pulls the cart 40 meters. And that would go here. So we're simply using our calculator. So work will equal 18 times 40 times the cosine of 35. Go ahead, type that in your calculator. Round everything. We're just going to say from this point forward, everything is to the thousands place. So it would be 589.789. And then your unit is whatever unit we use for force and distance. So it would be newtons meters. That would be my newtons times meters. I'm not picky at all about the unit though. Okay, so we're going to learn something new today. We're going to graph, but it's not difficult graphing. So in your note packet, go to page 8. Yep, I believe, we're on page 8. And I already told you homework 19 is due on Wednesday. We're starting 10.7 now, finishing out and getting ready for our test, which is next Friday. Okay, so what is a parametric equation? It allows you to represent related motions. It allows you to represent two related motions with respect to time. And we have to describe the movement along the curve. So how do we do that? So let's look at this equation here. This is example 1. We have two functions, two parameters. I have my x parameter, which says x in relation to time is equal to 3t squared. And then my y parameter is 2 times t. The interval that we are going to graph is between t equals -2 and +2. So the first thing you want to do is make a little t-chart. Make your t-chart real quick. It doesn't have to be a perfect table, but you want to create this table in your notes. So go ahead and make your table. It's just a 3-column table. 3 column, 6 rows. So make that real quick. 3 columns, 6 rows. You looking for the notes packet, Jaden?
I got it right.
Oh, okay. Can I help you get that organized? That would give me. Is that all pre-cal stuff? Oh, okay. That's a lot. So the main thing is we're going from -2 to +2, which is why in my first column, I only listed the t values from -2 to +2. So the next thing we're going to do is plug these 5 numbers. I'm going to start with my x parameter. So I want you to take every value we have for t and substitute it in the x parameter equation. So in other words, you're going to take, and I think it's easier to do it without a calculator, but for the first one, you're taking 3 times -2 squared. But if you use a calculator, if you're squaring a negative, you have to put it in parentheses. So I'm going to freeze my screen And I want you all to find your 5 x values. So you're substituting all 5 of these numbers into your x parameter. And you're going to give me 5 x values. So I'm going to freeze my screen. And then we can compare our answers. All right, so who agrees with my 5 x values? Who got that? So now we're going to repeat that process. We're going to still use these same 5 t values, but now we're substituting it into our y parameter. So take these numbers, substitute it in your y parameter, and fill in your y column. So now you're taking all of your t values and multiplying it by 2. All right, so that's what you should have. Who has that? So now to graph it, we take away this column. This column goes away. And you're going to graph it, your x and y. Go ahead and graph x and y. So I'm going to put a point starting at -12. X is -12. Put a point at -12, -4. So 5 points. Graph all 5 points on your coordinate plane. +12, -4. Yeah. So our first point is +12, -4. And then the curve is going to travel to 3, -2. 0 is going to make a little U-turn and come back up. But we start our curve at +12, -4. Yep, and when you do that, now be careful. This curve does not have arrows because there are only 5 points. So when you draw your curve, it has 2 endpoints. This curve has a start and it has an end. That is what your curve should look like. No arrows. No arrows, because your t value, my t value is not -infinity to infinity. It's -2 to +2. 5 points, no arrows. Now, well, let me go back. No arrows on the end. Now, we do have to describe the motion of the curve. And what I mean by that is I have to show if the curve is starting here and going down, or if it starts at the bottom and curves up. Now, we know that we started this curve at 12, -4. And so this curve started here and it went around. So we just have to put a couple little arrows, but these arrows are just describing the motion of the curve. And it really doesn't matter how many, just put like 2 or 3 on there. And that just shows that this curve, what direction it's going, and that's it. It's not bad, right? I don't think so. Let's do number 2. First thing you want to do for number 2, because we're going from -3 to +3. So go ahead and sketch your 3 columns. and your 8 rows. So just like before, we're going to take every single last one of these t-values. First, we're going to plug it into our x parameter and list those numbers in the first or in the second column. Then we're going to take those same 7 numbers, put it in our y. I didn't hear you. I was talking, so I didn't. What'd you say?
You have to do negative 3, negative 2. You have to do every single
You have to do every point.
You can't do like negative 3, negative 0. You have to do every single one.
Am I not like speaking clearly? Like, do I have a heavy accent? Like, what is the problem in the communication here? Because I keep saying the same thing and nobody's understanding me. So yes, you do have to do every point. Now, what I want to say is that for your y values, you can, like, this is why I don't put any numbers. You have an option to scale by whatever you want to scale. And when you fill in your y column, you will notice that we have decimals. That is why for my y-axis, I'm counting by a half. So for me, this is 1, this is 2, this is 3, that's 4. That's how I'm scaling it. I'm counting by 1/2 for y. Now for x, I'm still counting by 1. All right, so I'm going to freeze my screen. I want you to do the whole thing. Find all your points, graph it, and include your arrows. All right, go ahead and compare your curve and your table to mine. So when you see this on the test, I will tell you that we did not give you 7 t-values. I think you only have 5. So you still have to fill in the table completely and graph the curve, but it won't be this big of a table. This is kind of big. Well, last year I did bigger. I went -5 to +5, but I decided to, shorten it a little bit. Any questions? So I know we have to, loop back circle the block back to graphing, but I don't feel like this graphing is difficult. It's pretty straightforward. So what I want to do is I want to just get all of the graphing done. So in your notes, I want you to skip ahead to page 10. We have one more that we're going to do on page 10. So go ahead and create your T-chart. So again, you're going to take those 5 numbers, put it in T squared. Again, I think it's a lot easier if you just do it, because you know how to square a number without a calculator, so we can save some time here. And then just graph it. Now this one doesn't quite look like a curve. This one should look a little bit more pointed. So you can now start homework 19, like you can do the graphing part. All right, I'll give you a couple more minutes and then we need to move on to another piece of 10.7, which is writing a parametric equation. So writing an equation for the curve. So we're going to go to page 9. And you should have a little box on page 9 where it says notes. I want you to go ahead, let's write down our steps for our notes. The first step in the notes box is you're going to solve for t using x of t. That's the first step. Then after you do that, you're going to substitute whatever you got from step 1 in your y of t. The third thing you're going to do is simplify it. And then you also have to state the domain. And I don't know if you remember, but I did write the 2 red lights because we haven't talked about domain in a while. So they're on the board. The first thing you're going to look for is a square root, because you cannot take the square root of 0, or you cannot take the square root of a number less than 0. So that's the first thing we're going to look for, is do we have a square root? The second thing we're going to look for is, are we dividing by a variable? Because you can't divide by 0. If you don't have a red light, then our domain will stay all real numbers. So when I look at where I'm starting at, let's look at these two. Do you see a red light in either one of these parameters? No. So we started off good. Right now we're at all real numbers. All right, so now let's go ahead and work through it. Let's take our x parameter. Solve that for t. So I'm going to add 4 to both sides. And then I have to take a square root. Well, there goes my all real numbers. That's gone. So t equals the square is plus or minus the square root of x plus 4. So that's step 1. Step 2 is take what we got and put it in place of t and y. So I'm simply going to take this and put it right here. It's just going to go right there in the numerator. So this is a really easy y parameter. So my equation would be y equals, and then in the numerator, in place of t, because that's what I'm doing, I'm substituting for t, I have plus or minus the square root of 4. And that's my equation. So if I were to graph this on an interval, that would be the equation of the curve or the motion. Now let's state our domain. We started off good. We had all real numbers, but then we messed it up by taking the square root. So now we have a red light. So in order to find your domain, I'm going to take what's under the square root, which is only x plus 4. Set that greater than or equal to 0 and solve it for x. And don't forget that everything we do is in interval notation. And this would be your domain.